Hello students, let's continue chapter 14th of science of class 7th, that is electric current and its effects. Students, in my previous video I have told you that when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. In this video, we will study about electromagnet and electric bell. When electric current is passed through a coil of insulated wire wound around a piece of iron, it becomes a magnet. Such a magnet is called an electromagnet. We will perform activity 14.6 to make an electromagnet from a given iron nail. Wind a piece of insulated wire around an iron nail in the form of a coil. Connect the free ends of the wire to an electric cell through a switch. Place some pins near the nail. When electric current is passed, the iron nail becomes a magnet and attracts the pins. When electric current is switched off, the nail loses its magnetism. The electromagnets can be made very strong and can lift very heavy loads. Do you remember the crane about which you read in chapter 13 of class 6th? The end of such a crane has a strong electromagnet attached to it. The electromagnets are also used to separate magnetic material from the junk. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Many toys also have electromagnets inside them. Students, we are quite familiar with an electric bell. It has an electromagnet in it. Let us see how it works. Students, you can see the simplified circuit of an electric bell with the switch in off position. It consists of a coiled wire wound on an iron piece bent to form U-shape like a horseshoe magnet. A spring-loaded arm made of an iron strip is kept close to the electromagnet. This arm has a hammer attached to it at one end. Let us call it a clapper. A small gong or bell is also placed near the hammer. See, there is a contact screw near the clapper. Now let us switch on the circuit. Right now the clapper is in the contact with this screw. So the circuit is complete and the current flow through the coil. Due to the current flow, the coil becomes an electromagnet. The electromagnet then pulls the clapper toward itself. In this process, the hammer at the end of the clapper strikes the gong of the bell to produce sound. Let us see what else happened when the electromagnet pulled the clapper and we heard the hammer striking the gong. Look closely. Right now the clapper is not in contact with the screw. The circuit is broken. Now, so what will happen next? The current through the coil will stop flowing. Will the coil remain an electromagnet? No, it would not. The coil is no longer an electromagnet. As we know, it's the flow of current that gives the coil its magnetic power. So it no longer attracts the clapper. The clapper springs away from the bell back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated again and again very quickly. Thus the hammer strikes the gong every time the circuit is completed. This is how the bell rings. So students, this is the end of chapter 14th, that is electric current and its effect. We will meet again. Thank you.